Hello viewers, welcome to my YouTube channel. This is Sarayum. Today's subject is BEE, Basic Electrical Engineering, B.Tech first year, R22, R25 regulation for all branches CSE, EEE, Data Science, IoT, General CSE, AIML. First we need to know what is BEE, and it is a engineering subject that covers electrical quantities like voltage, current, resistance, power, energy, circuit elements like resistors, capacitors, inductors, DC circuits that follows Ohm's law, Current's law, Kirchhoff law, KVL, KCL, two methods, mesh and nodal analysis, AC circuits like phasors, impedance, reactance, resonance, power factor, electrical machines, power systems, electrical and safety. These all concepts covered in basic electrical engineering subject. For studying these concepts in engineering, this subject is introduced. First unit, DC circuits, direct current circuits. It deals with electrical systems where current flows in one constant direction. Flows in a particular direction is known as current flowing in electrical system. That they form the foundation for understanding more complex electrical and electronic systems like inductors, capacitors, circuit elements and capacitance. These concepts included in circuit elements R, L and C. R is nothing but resistor. Resistor is denoted by R. It is the ratio of voltage to the current. Is nothing but ratio of a resistor. Voltage is represented with V, current is represented with I. These are ratio format together known as a resistor. It opposes the flow of current. It is opposite to current. When R resistor increases, I current decreases. These are inversely proportional to each other. And resistor and voltage are directly proportional to each other. When resistor increases, voltage also increases. These two are directly proportional to each other. Converts electrical energy to heat. R is resistor, I is current, V is voltage. Followed by Ohm's law. Ohm's law is nothing but voltage equals to current into resistor. This together is known as a product voltage. Inductor is denoted with L. It stores energy in a magnetic field. It opposes the change in current. It is opposite to current in change is nothing but d I. Voltage across an inductor. These 3 points are included in inductor. V equals to L. L is a inductor. dL into dL by dt. Capacitor is denoted with a C. It stores the energy in an electric field. These two are somewhat different. Capacitor in electric field, inductor in magnetic field. These 2 points are different and some modifications are there for these two. It opposes the current, it opposes the voltage. It voltage across inductor, current flows through an capacitor. I equals to C into dV by dt. Voltage and current sources. Voltage and current sources. Voltage is the process of variable potential difference like a battery. It gives energy. Current source, it produces a constant current for low resistance. These sources are drivers of circuit behavior. For voltage and current sources, these two are main purpose for direct current circuits. Current flows in a constant direction and voltage that opposes the flow of current. We have two fundamental laws, Kirchhoff voltage law and Kirchhoff current law. These two are important for long questions. Kirchhoff voltage law is used for voltage purpose. Kirchhoff current law is used for current purpose. Sum of incoming current is equal to sum of outgoing current is known as KCL. Kirchhoff's voltage law, the algebraic sum of voltages across any closed loop is equal to 0. This is the condition. Summation is nothing but sigma. It is denoted with sigma. Sum of algebraic sum of adding total voltages around a closed loop is equals to 0. This is the condition for KVL. For a circuit, total voltages sum is equals to 0 for closed loop is known as a KVL. KCL is a property for measuring current purpose. Sum of incoming current, algebraic sum of current entering in a node is equals to sum of leaving the charging for exiting a node. Sum of incoming is equal to sum of outgoing. These two are equal. Sum of incoming minus sum of outgoing is equals to 0. Both are similar. Both are same. Circuit analysis. It can be done by using Ohm's law application for simple resistant circuits like a KVL based, KCL based. KVL based is depends on mesh analysis. For a closed current it is used. Nodal analysis is used for current purpose. For node voltages, superposition theorem, Thevenin's theorem, Norton's theorem. For simplifying complex circuits, it is used for identifying or determining unknown voltages, currents, power in the different parts of circuit. For finding different unknown voltages, currents, power calculating purpose, we use these three theorems: superposition, Thevenin's, and Norton's. DC excitation is the process of a circuit powered by a direct current source like a battery. Battery is an example for DC excitation. It is a process of a direct current source. Simple circuit like it includes resistors, capacitors, and inductors connected in series connection or parallel connection. Series connection is nothing but a side by side connection. Parallel is nothing but up and down, but connected with common points is known as parallel. Series is side by side connections. Objective purpose for this to analyze how current and voltages behave in the circuit. It can be calculated by using these circuits when subjected to DC supply. Superposition theorem, it states about linear circuit. Linear is nothing but straight circuit with multiple independent sources like voltages, currents. The response, voltage or current, is the algebraic sum of response due to each circuit acting alone. This is the process of superposition theorem. It explains about linear circuit, straight circuit with multiple independents like voltages, currents, battery. Like that, independent sources cannot depend on other, and it responds for voltage and current sources. The total sum will respond for acting alone, individual, not depend on other. First, we need to consider one source for distance. At a distance, turn off others. Replace voltage sources with short circuit. If voltage is there means then you short circuit it. Then current there means you can open it. For current you need to do open circuit. For voltages you need to short circuit. This is the first step. Then calculate the response. After you need to calculate the total circuit response, then you add the individual responses to get the total. Individually you calculate it, then after you add total individuals. Simplifies analysis of circuit with multiple sources. Continue the process for all the multiple sources. Thevenin's theorem, any linear two terminal. Here two terminal is used. Here single linear purpose we use this superposition theorem. For two terminal we use Thevenin's theorem, and network can be replaced by equivalent voltage, and two terminal network is replaced. In the place of two terminal we replace with the voltages VTH and resistance with RTH. Replace with VTH and RTH. RTH is nothing but Thevenin's theorem. Voltage replace with the VTH, resistance replace with the RTH. These are two terminals with a linear. These are the steps for Thevenin's theorem. For giving problem, just you write the steps and explain it in circuit format. For attempting, you will get 7 to 8 marks. Remove the load resistance. First you remove the load resistance in the diagram. Find open circuit voltage across terminals like VTH. Find circuit voltage with VTH. Find equivalent resistance. By using formula, you need to find a resistance. After voltage, you need to find a resistance. Then replace the network with BTH plus RTH in series. If the connection is in series combination, then you replace these terminals with VTH plus RTH. Simplifies complex circuit. It is used for difficult circuits. In single stage, source and resistance for easier load analysis purpose. This is the process of Thevenin's theorem. Now Norton's theorem. This is process of dual of Thevenin's theorem. It is also known as dual of Thevenin's theorem. Dual is nothing but 2 or double. Any linear two-terminal network can be replaced by an equivalent circuit source IN in parallel with an equivalent resistance Rn. If current is there means you need to write IN. If resistance is there means you need to write Rn. N is nothing but Norton's theorem representation. For IN, voltage by resistance with TH Thevenin's theorem property. Rn equals to RTH. Here Rn and RTH both are same. This is the condition. This is the relation we apply in Norton's theorem. Now use of Norton's theorem. Helpful when analyzing parallel circuit. It is used for analyzing or finding parallel circuit purpose. This theorem is useful, Norton's theorem. And time domain analysis. This is a process that studies about voltage and current changes with time in circuits. Changing voltage and current values in circuit, we use this analysis process. Charging and discharging of a capacitor. It is represented with Vt equals to V final into 1 minus e power minus t by R. C. For current, it is represented with It equals to I final into 1 minus e power minus TL by R. These are two formulas. It is applicable for capacitor. This is applicable for inductor. Difference between KVL and KCL. KVL is the property that applicable for voltage purpose. It is applicable for current purpose. It is possible in loops. It is possible in junction or node. Junction is nothing but some points, 2 or more points joining at a particular place is known as junction. Similar to node. Here for KVL, summation of voltage is equal to 0. For current, sum of incoming current equals sum of outgoing current. I is nothing but current, in is nothing but incoming current. This summation representation, sum of incoming current equals to sum of outgoing current. This is the formula for KCL. It is used for unknown or finding values for voltages. It is used for current purpose. These are differences between KVL and KCL. KVL is applicable for loop. For voltage, purpose is for energy. KCL is for node. It is for current applicable purpose for charge purpose. Example, 12 voltage battery. R1 is 4 ohms. R2 is 8 ohms in series combination. Then KVL purpose, step by step process. First draw the circuit. First draw the given circuit. Then battery is connected to R1. Then R2. Then back to battery. R1, R2. Then returns to battery. Calculate total resistance by R total equals to R1 plus R2. 4 plus 8 equals to 12 ohm. Using Ohm's law, I equals to V by R. Here we are finding R total. Means here representing with R total equals to total we got 12 R total. Voltage is 12. 12 by 12 is 1 ampere. Current is measured with amperes. These are unit. For current is represented with I. V is voltage, R is resistance. Here we are discussing about R total, so we represented with R total. KCL, Kirchhoff's current law. The algebraic sum of current entering a node or junction is equal to sum of current leaving a node. Summation I in equals to summation of I out. Incoming current equals to outgoing current. Steps to identify KCL and DC. First we need to identify the node which we are going to find. A node is a point where the two or more circuits elements meet. Choose a node where currents converge or diverge. First step is to assign current direction, which direction it is present. Assume directions for each branch current into or out, incoming or outgoing of the node. If the assumption is wrong, if the analyzing process is wrong, then result will be negative. If the process is correct, then it will be positive. Write the KCL equation. Sum of current incoming equals sum of outgoing. Just you analyze like I1 plus I2 equals I3, like example. Substitute Ohm's law if needed. If we need current value means you analyze with I equals to V by R. This is Ohm's law. Then this links node voltage to branch currents. Solve the equations. Use algebra to find unknown currents or voltages. For larger circuits, combine with KCL. Open equations. Loop equations. Circuit. What is a circuit? It is a node that connects 3 resistors to 12 voltage battery. Current like I1 enters, I2 enters, I3 leaves. Sum of incoming equals sum of outgoing. Sum of incoming I1 equals to, for example, 2 ampere, I2 equals 3 ampere, and I3 equals to sum of incoming. These two. 2 plus 3 is 5. So I3 equals to 5 ampere. Sum of incoming I1 plus I2. Sum of outgoing is minus I3 equals to 0. Here 2 ampere plus 3 ampere minus 5 ampere equals to 0. So it satisfied the condition. Verified. The current leaving equals to the total entering, or KCL entering total equals to current leaving. S. Sum of entering is equal to sum of outgoing. Node. It is a point where two or more circuits elements meet. Loop is a closed path that in a circuit format that starts and ends. Circuit is the closed conducting path through current flows. Branch. It is a path in circuit contains one or more elements. Node is applied for KCL like current. Loop is applicable for voltages, KVL purpose. Source is a battery or generator. Load is a load or component, both are same like resistor, capacitor, inductor. Circuit is battery with wires with resistors. These total together known as circuit. Branch, parallel network like 1 by 1. Circuit, whole closed path. Closed path is known as circuit. Branch is one path inside the circuit. These are the topics in first unit. All topics are covered. Now we are going to discuss second chapter. AC circuits. AC is nothing but alternating current like a peak, float, like that. Definition of AC circuit. Alternating current represented as AC circuits involves a current and voltage that vary sinusoidal waveform, like alternating one after other, like this waveform. Peak thrust form alternating one after other is known as alternating circuits. Current flowing is known as alternating current. Representation of sinusoidal waveform. Sinusoidal waveform is a sine form wave structure. It is represented with Vt for voltage equals to Vm sin omega t plus pi. These are two angles. Vm is the maximum point for voltage. Diagram for waveform like this represented with 0 Vt. Time is represented with horizontal. This is RMS value. Root means square value. Peak value is represented with Vm. M is the maximum point. Amplitude at the crest. This is peak point, highest point. This is the crest point, decreasing point. Then after it is again peak point. This is crest point. RMS, root means square value. VRMS equals to Vm by root 2. Shows as a dashed line like this. Dashed line representing the effective value one complete cycle for 0 from 0 to maximum voltage is 0. That implies negative back to 0. Here positive Vm will be present, then after negative Vm, here negative representation, then again positive representation, negative representation, positive representation, negative representation. Where Vm is the peak or maximum value, omega is the angular frequency. It is represented with 2 pi f. 2 pi is the angle 360 degrees with frequency f. Pi is the phase angle. Graphical representation. This is a graphical representation. It shows about smooth wave oscillating above and below zeros. Above 0 and below zeros. Peak and RMS value. Peak value, the maximum amplitude of the waveform, is known as peak value. RMS value, root means square value. VRMS equals to Vm by root 2. This is a formula. Vt equals to Vp into sin omega t. Here omega is the angular frequency, t is the time representation. Here squaring both sides, we need to find a sine form. So here into will be goes transpose like a by format. For finding sin square omega t, one formula is there, 1 minus cos 2 theta by 2. This formula is applicable or substituting here in place of a sin square omega t. Then after integrating 1 into dt, it will gives a t format. Cos 2 omega t by 2 will be integrated, converts to sine. These are the formulas. Sine of 1 dt equals to t. Integration of cos 2 omega t by 2 equals to sine 2 omega t by omega. These are two formulas we apply in our substitution with the limits 0 to t. After substituting upper limit and lower limit, we got this step. Vp square by 2t into t minus 0 equals to Vp square by 2. Applying upper limit and lower limit. Upper limit is t, lower limit is 0. Sin 0 is 0. Sin of 2 omega t replaced with the t, it will gives us 0 minus t. Here t will be cancelled. Multiply and divide t by t, it gives 1. Then we got by 2. Here we are going to find VRMS. So square term will be Vp square by 2. Square will be comes to this side, transpose like square root. Square and root format is cut. Then Vp by root 2. VRMS equals to, by calculating this term, 1 by root 2 value 0.707 Vp. Vp by root 2. This is the formula for calculating VRMS. Now another concept is power equivalence. It is used for DC voltages. RMS values are used because they are related to the power. It is representing for power format, power dissipated in a resistor like a heating. In the same way, DC voltage does. P equals to V square RMS by R. P equals to I square RMS into R. This is the sinusoidal format representing the effective value of AC voltage or current is important for it equates AC power delivery to an equivalent DC voltage. For equaling AC power values, we are equating DC values. Example, a 230 volts AC supply has a peak of about 325 volts, but its RMS value 230 volts is what matters for power calculation. Here 230 volts AC supply is peak maximum value about 325 volts of voltage, but RMS value is 230 volts. So for power calculation we use this concept. Another concept, phasor representation. It is for complex numbers we use this concept. It is a complex number representation. A phasor is a rotating vector. It is a rotating vector used for representing sinusoidal quantities like a simplified way. In a simplifying way, we use this representation. Instead of dealing with the time varying sine waves, we represent them as complex numbers in the frequency domain. Phasor representation is represented with pi. It is used for complex representation purpose by using sine angle with omega t plus pi. T is the time. Omega is the angular frequency. For calculating with a V maximum product format, it gives a V of t represented as phasor. This makes analysis of AC circuits with resistors, capacitors, inductors much easier. It is for 3 elements. It is easy process. When applying Kirchhoff's laws or solving for impedance, impedance is a L element. Like key points, sinusoidal AC will described by amplitude, frequency and phase formats. Peak versus RMS. RMS is a root mean square value. It is effective value like Vm by root 2. Phasors converts. It is a process of converting sinusoidal forms like wave formats to simple rotating vectors for easier circuit analysis purpose. Power in AC circuits. It's deal with the single phase AC circuits with resistors, inductors, capacitors. Power is not just one simple value like in DC direct current. Power in alternating current will be dealing with the single phase alternating purpose, not for simple value. Power in AC circuits is the combination of 4 topics: active or real power, reactive power, apparent power, power factor. Real power or active power both are same. The actual power consumed by resistance elements in the circuit is known as real power. The power that consumed or used by resistance elements in the circuit format is known as real power. It is useful for work like heating, lighting, mechanical work. It is used. The formula is P equals to Vrms into Irms into cos pi. Power in AC circuits is calculated by Vrms into Irms with a cos pi angle. Pi is the phase angle, where pi equals to phase angle between voltage and current with the units. Voltage is ohms, current with watts. Only resistors consume real power. Another concept is reactive power. This power alternating storaged or stored and released by inductors and capacitors. It does not perform useful work, but it is necessary for energy exchange in AC circuit or systems. AC system is the alternating current system. Name itself explains about alternating current with sinusoidal waveform by producting Vrms into Irms with sine format. Reactive power is represented with Q, whereas real power is represented with P. Difference is with the angle format. For real power we use cos pi. For reactive power we use sin pi. It is represented with P. It is represented with Q. Unit volt ampere reactive. It is also known as VAR. First letters of all these concepts. Apparent power, the total power supplied by the source or circuit combining both real power and reactive power is known as apparent power. It is represented with S. Product of VRMS into IRMS is known as apparent power. It is the vector sum of a real and reactive power. For squaring the terms, we will get the value vector sum S square equals to P square plus Q square. P is the real power, squaring term, plus reactive power Q. For power factor, it is the format of ratio. Ratio of real power is P to apparent power is S. It is denoted as cos pi with the power factor. These three are equal to each other. Power factor equals to cos pi is equals to P by S. PF power factor equals to 1. Then it is purely resistive in nature. That load ideal or efficient. For power factor is less than 1, it is represents as presence of inductive or capacitive elements. High PF, high power factor terms means efficient utilization of electrical power, and low power factor causes losses like required some correction. Using capacitors, general case we use RL combination. R is the resistance, L is the inductance combination. It is represented with Z equals to under square root of R square plus XL minus XC whole square. Phase angle is represented with pi is equals to tan inverse of XL minus XC by R. Circuit with RLC, 3 elements together: pure resistive, pure inductive, pure capacitive. These 3 circuit elements in circuits with RLC elements concept. It is by using voltage and current are in phase, like power factor equals to 1. It is also known as ideal stage. Only real power is consumed here. It is with R resistance. For L inductance, pure inductance circuit, current lags voltage at 90 degrees, straight 90 degrees angle. Power factor equals to 0. Here no real power consumed, only reactive power is consumed here. For CC is the capacitive, pure capacitive circuit. Current leads to only voltage. It is also with 90 degrees with a capacitor. Here inductance L. Again no real power consumed, only reactive power is consumed. Combination of all 3 elements together, RLC. RL circuit, current lags voltage and by angle pi. Combination of all 3 terms, impedance equals to, impedance is nothing but Z representation equals to square root of R square, resistance square plus XL whole square. This is the term of inductance. For RC circuit, current leads voltage by angled pi, angle pi representation. Both real and reactive power present. Impedance Z equals to square root of R square plus XC whole square. Resistance plus C is XC term squaring. RLC, these 3 together, general case we use with 3 terms: resistor R, inductor L, capacitor C. Impedance Z representation equals to square root of R square plus XL minus XC whole square. This phase angle depends on whether in inductance, reactance and capacitive reactance XCR reactance formats. This is for inductance, this is for capacitive representation. Now, series versus parallel combination. Series combination is elements connected one after other with same current flows. Voltage only differs here. Whereas parallel circuit, elements connected across the same voltage source, current differs, voltage same, opposite to each other. Analysis uses phasor diagrams and impedance admittance methods we use in this case. It is also known as impedance. Resonance in series RLC circuit occurs when inductance reactance equals to capacitive reactance. Here both terms are equal, and at resonance impedance is purely resistive in nature. Z equals to R. Current is maximum, it is in high level for a given voltage. Power factor equals to 1, it is the ideal stage. Resonant frequency, it is representation of FR equals to 1 by 2 pi under root LC. L is inductance, is the capacitance. It is a resonant formula. It is used in radio tuning, filters purpose, oscillators purpose and communication systems. We use this concept. Now we are going to discuss transformers concept. It is a introduction. The alternating current can be easily transferable from low voltage to high voltage or high voltage to low voltage is known as transformer. Alternating current can be easily transferable from low voltage to high, low to high and high to low. Alternating current can be raised or lowered. It is increased or decreased as the requirements. In the different stages, electrical networks as generation, transmission, distribution and utilization concepts. It is possible with a device called transformer. It can be increased and decreased. Definition of transformer. This is the introduction or purpose of the transformer. Now we are going to discuss definition of the transformer. It is a static device which transfers the electrical power to energy from one alternating current circuit to another with the desired change in voltage or current and without any change in the frequency. It has two types of transformers, step up transformer, step down transformer. Now we are going to discuss types. A transformer used to increase the voltage is called step up, increasing voltage. Step down is a decreasing voltage. Name itself explains about transformer type. Now application of step up transformer. It is used to increase the voltage at generating substations for transmission. This is the purpose application. Now step down transformer application. It is used to decrease the voltage. As the name implies, at the substations for the consumer's use. How consumer want, it is applicable for that purpose. Now working principle of a transformer. How it works, by which principle it works, we are going to discuss now. A transformer works on the principle of electromagnetic induction concept and mutual induction between the two coils. It is the principle. Now we are going to discuss what are windings and coils. What is the diagram for it? Now we are going to discuss. It consists of two winding electrically separated. These are two winding electrical separators. This is the laminate core we use for transformer. This is the example for simple transformer structure. We use secondary winding and first primary winding with N1 and N2 turns. This is the AC supply or AC source with V1 voltage E1. Primary, this is the primary winding for N1 turns. This is the secondary winding for N2 turns. E2 and V2 are the loads. This is the basic structure of simple transformer. The windings which is connected to the supply. These are windings for supplying primary winding P and other winding on which the load is connected. S load is connected is called a secondary winding. This is the secondary winding. For V1 and E1 sources we use primary winding N1 turns. When primary winding is excited by an AC supply, then a current flows through it by primary winding. This is a primary winding. When it is excited, the AC current will be flows through it. When secondary winding is excited, then secondary winding current will be pass through it. This current produces an alternating flux. It is denoted with pi in the core. This is the core, outer part, laminated core. This flux links with both windings. It is linked with both windings. Flux is linked with two windings, primary winding and secondary winding. Because of it, it produces self-inducted EMF. According to the Faraday's law of electromagnetic induction, in the secondary winding, if secondary winding is closed through the load, mutually induced EMF in the secondary winding through circuits circulates current through load. Thus, this electrical energy is transferred to the primary to secondary with the help of magnetic core. This helps to do this process. High voltage HV and low voltage windlags will be produced in this process. The winding connected to the higher voltage circuit is called high voltage, also known as HV winding, while that connected to the lower voltage is known as LV voltage or LV current winding. In case of step down transformer, the high voltage winding is the primary and low voltage is the secondary. Primary is high, low voltage for secondary. These two are opposite. In case of step up transformer, high voltage winds to the primary and high voltage winding to the secondary. Next concept is transformer on DC supply. A transformer can not be generated or operated on DC supply if a rated DC supply is applied to the primary of a transformer. The flux produced in the transformer core will not vary but remains constant in magnetic field, and no EMF will be induced in the primary and secondary winding. This transformer cannot operate or cannot perform DC circuit. If a DC circuit will operate, then we need to supply the primary transformer. The flux should be produced in this process. If no self-induced EMF is produced in primary winding, it will opposes the applied voltage. Further resistance of primary winding is low. Therefore, a heavy current will be flow through the primary winding, which will result in the damage of the winding. It will lead to damage in winding for the transformer. This is the reason that direct current is never applied to the transformer. So for this reason, this is the main reason. So we not use the direct current for transformer. We use alternating current. This is the main reason. They will ask what is the reason we not use DC current in transformer. Means you need to write this method, this process. Now transformer classification. It is classified into two types, single phase and three phase. In single phase According to construction, there are three types of transformers are classified. Core type transformer, we use a single magnitude in this circuit. Shell type transformer, here we use double magnitude circuits. For binary type transformer, we use distributed magnitude circuit. According to function, there are two classifications are there: power transformer and distribution transformer. For power transformer, we use step up and step down transformer. Distribution transformer, instrument transformer. Distribution transformer is with a single one, it will be distributed for all. Instrument transformer is with current and potential, two cases: current transformer and potential transformer. It is also known as CT. Potential transformer is denoted with PT. Special purpose transformer, it is used for 5 cases: Scott connection, V connection, pulse transformers, auto transformers, welding transformers. We use auto transformer and welding transformer. According to type of cooling, we will use this cooling system for more usage of transformer for heating. More time we use means it will get heated. For cooling, that we use this type of concept: air cooled transformer, oil cooled transformer. Air cooled transformer will be cooled by air naturally. Oil cooled transformer will be cooled by pouring oil for the transformer. According to location, here there are two types of transformers: indoor transformer and outdoor transformer. Indoor transformer is used for inside purpose, outdoor transformer is for outside. It is the location cases. For frequency, we use small frequency and high frequency. Low frequency like 50 Hz. Frequency is measured with hertz. High frequency for high frequency transformers, pulse transformers, we use somewhat above 50 Hz. According to rating, three cases: low rating, medium rating, high rating. Transformers. Construction of a transformer, it is a static device of a transformer and it is constructed by simple case, no moving parts like stable parts like a core. It is the protection purpose: winding, coils, tank for storage, transformer oil for cooling purpose. Conservator is also a part of construction. Breather, terminal brushes for brushing purpose. Explosion vent, oil gauge and other. This is lessly used case. Purpose of each part of the transformer: magnetic core is used for providing or protection purpose like low reluctance. For the magnetic flux purpose, core is made up of laminated stamping for reducing current losses like eddy current losses. Winding or coils, these are made up of copper conductors and are placed with a core. The winding is connected to the supply, is known as a primary winding, and the winding which has connected to load is known as secondary winding. This is a diagram. This is a core. We use high transformer and low transformer. Here oil is placed for cooling purpose. These are the labeling conductors. This is for vent purpose for transferring. This is the diaphragm. This is transformer connection. These are tubes for transferring. These are terminals. We use brushes for this. These are wheels. Breathers. These are breathers. Conservators. These were conservators. Oil gauges purpose is oil storage. This is the diagram. Now transformer tank, it is the part is for proper containing tank for storing purpose. The transformer with core and winding is housed in proper container contains a transformer oil is called a transformer tank. Similarly, we use tank for storing water in our day-to-day life, like house purpose tanks. Here we use transformer tanks for storing oil. Transformer oil. What is a transformer oil? This is the insulating oil which can be used in the tank of transformer is known as a transformer oil. It is a cooling agent. It proves three functions. Carries away the heat produced in the core and winding. Additional insulation purpose we use this, and it protects the insulation with the dust and moisture purpose. These are three main purposes for transformer oil. Conservator is a function that maintains the oil level in the tank. This much oil is present, like that it says or maintains about the oil level and provides a space for expansion of oil for temperature. If transformer increases or decreases like that, and it decreases or reduces the rate of oxidation reaction with oxygen of oil, because it ensures some surface of oil like less exposed to air, breather. It is a function that prevents the entry of moisture in the air and allows dry air into the transformer. Moisture reduces the dielectric strength of the coil. Terminal brushing. This is the connection from the transformer winding are brought out by means of brushes mounted on the transformer tank. Explosion vent or a pressure relief valve. It produces the instantaneous, like a step-by-step revealing of a dangerous pressure and protect the transformer tank against the explosion. It will save from the dangerous pressure. Simply words. Oil level indicator or a oil gauge for indicating the level of oil in the conservator, and an oil indicator level is fixed to it. Somewhat level is fixed for that, and it is essential for oil levels in maintaining the level for oil. Below level it causes some danger cases.